Hello and welcome to Guessing the Methods exam part 5. Now last year I guessed it, but this year my past students are doing it. They're awesome. You should go and check them out. They've got this tutoring company. Sign your brother or sister up to it so they're ready for next year's external. Alright, this is the stuff they do. Let's get started. Tech free, multiple choice, have a try. Alright, I'm going to have a go. There's a function there, right? So we know what a function is. It looks something like this. I don't know what it looks like. Alright. We're told that there's a point here, and we're finding the tangent to the point. So that's our goal. Now, if you're thinking about tangents, you're thinking about derivatives, you're thinking about gradients, so we need the derivative of that. So f of x equals 2x minus 5 to the power of negative 1. Alright, so I'm going to slowly move through this one. So still going to write f of x equals u to the negative 1 there. So just letting 2x minus 5 be u. So the derivative is going to be equal to the derivative of that, negative u, decrease the power by 1, negative 2, times the derivative of whatever u was, 2x minus 5, so times 2. So I get negative 2, u isn't u, it's 2x minus 5, to the power of negative 2. We can rewrite this as negative 2 over 2x minus 5 squared. Alright, what have I done? I'm nowhere near the answer yet. All this is the derivative of 1 over 2x minus 5. Why did I find that? Because I want to know the gradient at this point here when x equals 2. So I can write that as f dash of 2 and sub 2 into my derivative function. 2 times 2 minus 5 squared. So that's negative 2. 4 minus 5 is negative 1. Negative 1 squared is 1. So I get a negative 2. Alright, great. The gradient of that line is 2. So I can say y equals negative 2x plus c, where that is the equation of that line. So that means that my answer is probably A or B. I don't know which yet. But if I had a point, if I knew a point, so I know that this point here is 2 something. So let's find out what that point is by subbing 2 into the original function. So f of 2 equals 2 times 2 minus 5. So 4 minus 5, negative 1. Okay, so that point there is 2, negative 1. And I can now sub that point, 2, negative 1, into this. Negative 1 equals negative 2, 2 plus c. Negative 1, that's minus 4, so I'll move that over here as positive 4. C equals C equals 3, not negative 3. Alright, I am finished. Therefore, y equals negative 2x plus 3. My answer is B. Done. A little bit of work for a multiple choice, but there we are. Alright, celebrate. Next question. Alright, great question here. I love this because it's like, well, actually, try it first. I love it. I love it because it's a normal distribution question on a tech-free exam. Tech-free. So a very good idea with a question like this is to draw a picture. So that's what we're going to do. So normally distributed. The second I see the words normally distributed, I just do this. Like just as a knee-jerk reaction, that's what I do. Has a mean of 1 kilogram. 1. And it says it has a standard deviation of 20. Now I do something non-standard here. I don't know if other maths teachers do this, but I kind of write this 20 like this. Now the 20 is a 20 grams. This is a 1 kilogram. So like I got to keep my units the same. So let's say 1,000 grams is our mean and 20 grams is our standard deviation. This is useful, and especially for questions like this. All right, select the option closest to the probability that the mass of a given bag will be between 1.02 and 0.98. Okay, so 1.02 is right there. 1020. And here one standard deviation in the other direction, 0.980, is 980. Now, a thing that you should know is that the area between here and here is approximately 0.34. There's a 34% chance that something is between the mean and one standard deviation above it. There's a 0.34 chance that something is one standard deviation or less below the mean, right? And we want those together. So 0.68. 0.6826 is our answer. Now, if you've never seen this before, let me find you a picture. A quick Google later, and here we have our picture. All right, so this sort of a picture, this is something that you should have in your head. So the way that we're looking at this is one standard deviation above or below, there's a 68% chance that something is between those two. And so we can do like a smaller bit here and say that that's 34%, that's half of 68. If we go further out, two standard deviations either side, there's a 95% chance that something's between those two. You can see the place where I found this picture has done an interesting thing and said, hey, you can do lots of different stuff with this. So I could imagine a multiple choice question where they said, hey, let's say this multiple choice question, where instead of saying between 1.02 and 0.98, I can imagine that they might say between 0.96 and 0.98. So if they said it was between those two values, you would need to be able to calculate this number here, which is 0.135 or 13.5%. How would you be able to calculate 13.5? Well, you know that this piece here is 34%. You know that this piece here is 47.5%, which is half of 95. 47.5 minus 34 is 13.5. So I could see a question like that. That would be cool. I hope you're not listening, QCAA. All right. This picture, you should have that in your brain. If you don't, that's something you've got to work on. That's the actual question we just did. Celebration. Next question. All right. Derive this, hence determine this. Have a try. All right. This is a good question. It's a good question. It's a integration by recognition question. So let's go. That tells us what to do. Derive this. So let's do that. All right, so I might want to mess with this a little bit. So y equals 1 plus 2x squared to the power of 1/2. Okay, cool. You can see this is kind of like a function inside a function, so it feels like we should be doing the chain rule again. So we'll just say y is equal to u to the half, where u is 1 plus 2x squared. The derivative, dy dx, is going to be the derivative of that. This feels like deja vu from 2 questions ago. The derivative of that, so negative 1/2 u, and decrease the power by 1. So that becomes negative 1/2. But we need to multiply that by whatever the derivative of u was. So the derivative of 1 plus 2x squared is 4x. All right, u isn't u. U is 1 plus 2x squared. So half 1 plus 2x squared to the power of negative 1/2 times 4x. All right, so a few things I can do with this. I'm going to say that dy dx equals, I see this 4 being multiplied by 1/2, so that's 2. I might put the x out the front as well. And then what's left is this part here. Now that's going to be over, because it's a negative power, right? So 1 plus 2x squared, and it's a negative power of 1/2. So that's on the bottom, and a power of 1/2 is a square root. Okay, the derivative of this is this. And then it says, hence, determine an antiderivative of this. So here's how we go about that. This proof by recognition thing. Your next step is to say, well, if the derivative of that is that, then the integral of that is that. With respect to x equals this. Right. Now, it says we want to find an antiderivative of 6x, blah, blah, blah. Now, we don't have an antiderivative of 6x. We have an antiderivative of 2x, right? So, if I multiply both sides of this equation by 3, with respect to x equals 3, 1 plus 2x squared. Right, that 3 can come into there now as a 6. Right, so the integral of 6x root 1 plus 2x squared equals 3 square root 1 plus 2x squared. I've done my job. Derived this, hence found out what the integral of that is. My answer is 3 square root 1 plus 2x squared. Proof by recognition could be a multiple choice question, could be a short response question. There's a bit in there. Okay, let's move on to the short responses. All right, here we go. Have a try of this question, and then I'm going to do it. Okay, so we've got a function here, f of x equals 2x on x squared plus 1. The first bit says determine the x coordinate or for the stationary point or so there might be one stationary point, there might be more than one stationary point, but keep an eye out for this like S thing. It might mean more than one answer. Okay, so we know how to find stationary points. Find a derivative and then let the derivative equal 0. Now, it feels like the logical thing to do would be like a quotient rule because we've got something on the top and something on the bottom. I'm going to not do the logical thing. I'm going to instead write f of x equals 2x times x squared plus 1 to the negative 1. And so writing x squared plus 1 to the negative 1 is the same as x squared plus 1 on the bottom. Writing it like that allows me to avoid the quotient rule. Not a fan. And I'm going to do the product rule instead. A very easy thing to stuff up. So make sure that you sort of make some notes for yourself. I'm going to call this U. I'm going to call this V. And then right the way up here, I'm going to write U, U dash. I'm going to write V. I'm going to write V dash. And I'm just going to write everything down. So U is just 2x. U dash is going to be really easy. That's 2. V is x squared plus 1 to the negative 1. It's all of that. And then V dash, I might have to do a little bit of work there. Feels maybe a little bit chain rule-y again. So not to confuse things, I'm going to call this W. So I'm going to say that V is equal to W to the negative 1. So the derivative of V is equal to whatever the derivative of that is, so negative W negative 2, times whatever the derivative of W is, which is 2x. So that's negative 2x W, which is x squared plus 1, to the negative 2. All right, so that is my V dash. So now that I've got U, U dash, V, and V dash, I can put it into a product rule formula. I'm going to get rid of that in a second. So we have U, V dash, so 2 at x times negative 2x, x squared plus 1 to the negative 2, plus V, U dash, 2 bracket x squared plus 1 to the negative 1. What's a good idea here? I feel like from here, these negative powers are more trouble than they're worth. This is tech-free. So this is 2x times negative 2x. So that's negative 4x squared. And then this thing here is x squared plus 1 squared. Great. And then this bit is just the 2 over, and then just x squared plus 1. Now, are there other answers? Are there other ways to express this? Yes. If you'd done the quotient rule, your answer might look different. If you want to, you can multiply top and bottom here by x squared plus 1 and make it into a single fraction. For the purposes of what I'm doing here, though, I think that's enough. All right, I'm just going to get rid of this. This is just kind of a little bit of side working to figure out what that v dash was. Let's actually answer the question. Determine the x coordinates for the stationary points. So to do that, we let f dash of x equal 0. So f dash of x, this is f dash of x right here, right? That's where f dash of x began. This is where I've finished up with f dash of x. So I'm saying f dash of x, 0 equals this. And I'm sort of looking ahead a little bit. I feel like it is going to be easier if I turn this into a single fraction. So I'm going to go, this can remain how it is, negative 4x squared. The whole thing is going to be over x squared plus 1 squared. In order to make this fraction x squared plus 1 squared, I need to multiply top and bottom by x squared plus 1. So I need to multiply this 2 by x squared plus 1. 2 x squared plus 1. Oh my gosh, look at this equation. How on earth are we going to deal with it? You've heard of the null factor law. We can kind of use a similar idea to the null factor law, right? This is a fraction equal to 0, right? Now, how could a fraction be equal to 0? Well, you can never divide by 0. You can never divide by 0. That doesn't do it like you. That leads to a math error. That's an undefined answer. The only way that a fraction can be equal to 0 is if the numerator is equal to 0. So this tells me that 0 must be equal to negative 4x squared plus, why don't I expand the numerator while I'm at it? 2x squared plus 2. That means that 0 is equal to negative 2x squared plus 2. And it feels like now we can just solve that relatively easily. Negative 2, negative 2x squared. Divide both sides by negative 2, we get x squared equals 1. And so x is equal to the square root of 1 plus or minus. My stationary points there. Stationary points at x equals 1 or x equals negative 1. Now, there might be an issue. I don't know. I said that we can kind of ignore the denominator and just do this thing, right? I really wouldn't feel comfortable doing this unless I double check that these numbers don't cause a math error back in our original equation. And by that I mean, if I put 1 into the denominator, if the answer is 0 there, the denominator is equal to 0, math error, undefined, doesn't work. Let's put the 1 in there. 1 squared plus 1, that's 2. 2 squared, 4. Great. The denominator when x is equal to 1 is 4. That's not causing a math error. So this is a valid solution. What about the negative 1? Negative 1 squared is 1 plus 1 is 2. 4. Great. The denominator is not 0. So valid solution. 1 and negative 1. These are my two stationary points done. I'm going to get rid of this and start working on part B, but I think what I need to keep maybe is my derivative. So I'm just going to take this over here and write it as f dash of x. So I'm just taking that and moving it over there. Just note that I've expanded the top here and simplified it. That is the same as that. That's my derivative function. Now there's a lot of different ways to go about this part B, but the way I'm going to do it is look for a point of inflection, right? So the question I'm asking myself is, where is the point of inflection, right? Now, points of inflection can only happen where the second derivative is equal to 0. That doesn't mean, and I mentioned this in a previous video, that doesn't mean that there is a point of inflection there, but a candidate point for a point of inflection is where the second derivative is equal to 0. Okay, so maybe where f dash dash x is equal to 0. So I'm going to have to find the second derivative of that. So given I avoided the quotient rule last time, why don't we use the quotient rule this time? So u is equal to negative 2x squared plus 2. V is equal to x squared plus 1 squared. U dash is equal to negative 4x. V dash is equal to 4x x squared plus 1. And the last piece of the puzzle with the quotient rule is v squared, the bottom thing squared. So x squared plus 1 squared, squared. So it's x squared plus 1 to the power of 4. Now that I have all of that, we put it all together, and we can say v u dash, so that's negative 4x times x squared plus 1 squared, minus u v dash. So how can I put them together neatly? Let's just do it. So we got 4x x squared plus 1 bracket negative 2x squared plus 2, close the bracket, all over v squared, x squared plus 1 to the power of 4. Oh boy. Now for ease of working from here, it probably makes sense to simplify this somehow. Maybe. Do I want to? Yeah, I think I do. I see common factors of x squared plus 1, so I can sort of bring that out the front with my numerator. So what I noticed was common factors of x squared plus 1 in this term, that's a single term, and in this term, x squared plus 1, x squared plus 1, so I brought that out. I also noticed common factors of negative 4x, so I brought that out the front as well. So interpreting this, it's negative 4x times x squared plus 1, and then what do I need to multiply that by to make that? And it's just x squared plus 1. And then this again, and what do I need to multiply that by to make this? It's this bit here, this negative 2x squared plus 2. All right, so I noticed some things here. What I notice is x squared plus 1 to the 4, and then I notice this x squared plus 1 there. So I can actually cancel, whoops, let's try again. I can actually cancel this out with one of these. So we end up with a 3 there, not a 4. And then I have this x squared plus 1 minus 2x squared. So in other words, x squared plus 2x squared. So that's 3x squared. And 1 minus 2, minus 1. So there, this piece here is going to be 3x squared minus 1. So this is the answer I got, and it's wrong. And the reason I know it's wrong is because I stopped here, because this process is enormous. And I thought to myself, gee, if I've gotten this wrong, my life's going to get really hard. So I double checked everything, not everything, the things that people make mistakes on. And here's where I found my mistake. From this line to this line, this shouldn't be a minus. This should be a plus, which means that I end up with negative 4x, x squared plus negative 2x. So I don't end up with 3x here. I end up with negative x squared. And then 1 plus 2. I don't end up with negative 1. I end up with positive 3. Find those opportunities where you think, you know what, this is a place where a person can make a mistake, and take an extra minute. All right, so why did I find the second derivative? Where the point of inflection can only happen where f dash dash of x is equal to 0. So same trick that we employed earlier, f dash dash of x is equal to 0. If that's the case, then the numerator would need to be equal to 0. And then we get an actual null factor law. So we can say, therefore, this would be equal to 0. So therefore, negative 4x equals 0. So x equals 0. Or this would need to be equal to 0. Negative x squared plus 3 equal to 0, which means x squared 3, x square root of 3 plus or minus. So it looks like I have 3 potential points of inflection. X equals 0, the square root of 3, and negative the square root of 3. So there they are, my potential POI. Now a point of inflection is where we move from concave up or concave up or concave down, right? That's the changes. Now the second derivative is positive. positive when it's concave up, and negative when it's concave down. These are our potential changes from concave up, concave down. So now let's create a little table for ourselves, x, f dash dash of x, and let's examine some key points, right? Now we know that the second derivative is 0 when x equals 0. It's also 0 when x equals plus or minus root 3. So root 3 negative root 3. Okay. The other points that I'm very interested in, this point, this point, this point, and this point, because I'm very interested in changes of concavity. So let's go with 1, something larger than root 3, so I don't know, 3, and negative 3. What is the second derivative at each of those points? Well, there's my second derivative. If I sub in 1, negative 3, and 3 into that, I'll get some numbers. I'm just going to do it. Okay, I did it. So, what does all of this mean? Well, this means that f dash dash of x is less than 0 here, right here. But it changes to being more than 0 here. And then it's less than 0 here, and then it's more than 0 here. So when is it concave down? And this is, we've finished the question, right? Determine the interval or intervals where f of x is concave down. It's concave down wherever it's less than 0. And from negative root 3 all the way over here, you can see it's less than 0, right? So if x is less than negative root 3, then it's concave down. Between here and here, it's positive. It's positive. So it's concave up here. What about between here and here, 0 and root 3? Well, between 0 and root 3, it's also concave down. But from root 3 onwards, it's positive, it's concave up. So that is our final answer. Determine the intervals for where f of x is concave down. It's concave down where x is less than negative root 3 and x is between 0 and root 3. Now, what does it actually look like? Now, this is a tech-free paper, so you won't be able to see it, but given this is just a video, let's take a quick look at what the actual original graph 2x on x squared plus 1 looks like. This is the graph right here. That's the original graph, right? Now, the intervals that we came up with, x is less than negative root 3. Let's take a look. X equals negative square root 3. From here, over here, all the way over there, you can see it's concave down. It's like that, right? From here, all the way to here, so let's go x equals 0. This portion here is concave up. You can catch some water in there, right? Concave up. From here to square root 3, x equals, from here to here, concave down again. And then from here onwards, concave up. You can catch some water in it. So our intervals again are from here to here, concave down, and from here off to infinity, negative infinity, concave down. What a massive question. There's probably other ways to do this question. People have talked about like third derivative tests. People do these things in other ways, but this is how I would suggest you go about it. You can solve inequalities. Other people would solve inequalities to do questions like this, but that was a big one. Normally we'd do one more question, but that one was big. We did the product rule, we did the quotient rule, we found stationary points, we found concavity, we found points of inflection. We talked about like some weird like dividing stuff. So, big one. We'll be back in the next video with some more stuff. This has been part 5. Thanks, as always, to my friends here. They absolutely nailed that one. Go and check them out. See you in the next one.